Hello, welcome children to another video. This is meant for yet another video meant for the IIT exam. Today we are going to discuss a few questions, a few simple or moderate level, simple and moderate level, dealing with some possible questions for the IIT exam. Let's go through the questions. Okay, first one. What is the mass of precipitate formed when 50 ml 16.9% solution of silver nitrate mixed with 50 ml 5.8% NaCl solution? That is the question. Very simple question, only a moderate level question only. So what is the reaction dealing with? The reaction dealing with is so simple. Silver nitrate react with NaCl. You are getting AgCl plus NaNO3. That is a reaction concern, all of you know. So 1 mole silver nitrate react with 1 mole NaCl. You get 1 mole AgCl and 1 mole NaNO3. Okay. And here we have 50 ml 16.9% silver nitrate. Okay. And 50 ml 5.8% NaCl, right? So what is the number of moles of silver nitrate? Number of moles of silver nitrate will be mass by molar mass. It is 16.9 divided by 2. That will be the mass. Why 16.9 percentage. In 100 ml, it is 16.9 gram. So in 50 ml, it will be half of that. So it is 16.9 divided by 2. This is the mass of silver nitrate, and molar mass of silver nitrate 108 plus 14 plus 48 170, right? It is 170. So approximately this will come out to be 1 by 20, isn't it? It is approximately 1 by 20. So it is, you see that 169, 16.9, 170. So 16.9, 17 cancels and you get 1 by 20 mole. So approximately it is 1 by 20 mole silver nitrate. Fine. What is NaCl? NaCl 5.8%, 50 ml. Once again, the mass of NaCl will be 5.8 divided by 2. Because in 100 ml, 5.8 gram. So 50 ml, it will be by 2. Okay. So what will be the number of moles divided by formula mass? 58.5. Once again, it is very close to 1 by 20, isn't it? So the same pattern. So this is 1 by 20. This is also 1 by 20. Approximately, I mean close figures. And they react 1:1 ratio. And the product obtained here will be 1 mole. So AgCl obtained will be 1 by 20 mole. Right? What will be the mass? It is 1 by 20 mole into molar mass of AgCl 143. Sorry. It is silver 108. Silver 108 plus 35.5. Yeah, that is 143.5. 143.5. So it is 143.5, which will be by 0 means 14.3 something divided by 2 means 7 gram, approximately 7 gram. 3.5, 14. Option 2 will be the correct answer. 7 gram. Right? A moderate level question from the stoichiometry part. Okay. Next question. A reaction takes place in various steps. The rate constant for first, second, third, fifth steps. Where is fourth step? Okay. First, second, third, and maybe it is fourth step, or it's given as fifth step. Okay. Are K1, K2, K3, K5. Okay, no problem. The overall rate constant is given by K2 by K3 into K1 by K5 whole raised to half. The activation energies are 40, 60, 50, 10 respectively. Overall energy of activation. A very simple question. All of you know K is equal to Arrhenius equation A e raised to minus EA by RT. So whatever happens on K will be reflecting on EA in the exponential way. It is in the exponential way. So if you take K2 by K3, it will be EA2 minus EA3, isn't it? K2 by K3. What will be the EA correspondingly? EA2 minus EA3. If it is K1 into K2, EA1 plus EA2, like that, because it is coming as an exponential factor, right? So here we have K2. K2 means EA2. I am taking 60 as such. Then there is K1 raised to half. K1 raised to half means root K1 will be EA1 by 2, isn't it? So EA1 by 2, this by 2. So it is plus 40 by 2. Then K3 means 50. So it is minus 50. And K5 raised to half, minus again. K5 raised to half. So it will be minus again 10 by 2. So how much you get? 60 plus 20 minus 50 minus 5. 60 plus 20, 80. 80 minus 50, 30 minus 5. So it is 25, the final figure. 25, option C is the correct answer. So whatever K is manipulated, EA will come as an exponential form. That's all. So when you take K is equal to, overall K is equal to K1 into K2, overall activation energy will be EA1 plus EA2, so on. Right? That's it. Next question. Consider the reaction A giving 2B. It is A gas giving 2B gas with the K value given 0.1 molar per minute. 0.1 molar per minute. If the initial concentration of A is 0.5, then which is the correct graph? Initial concentration of A is 0.5 and obviously this is nil. What is the correct graph? So first of all, it's a matter of understanding what is the order of the reaction. What is the order of the reaction? It is basically zero order kinetics. How do we come to know it is a zero order kinetics? It is from the unit of K you can understand. Unit of K given molar per minute. Molar per minute means mole per liter per minute. That is for a zero order kinetics. For a zero order kinetics, K unit will be concentration by time. That is the unit of the rate itself. Okay. So it is basically a first zero order reaction. It is a zero order reaction. Right. And for zero order reaction, we can talk about time for completion. We can talk about time for completion, time for 100%. That is time for completion. Time for completion is equal to R0 by K. Isn't it? R0 by K. Time for completion. What is R0? R0 given is 0.5. Isn't it? 0.5. So it is 0.5 divided by K is 0.1. So it is 5 minutes. Time for completion is 5 minutes. So here at 5 minutes the reaction is not completed, out. Here at 5 minutes the reaction is not completed, out. Here at 5 minutes the reaction is completed. You can see the reaction is completed. Concentration of B remain constant. Means the reaction is completed. Here 5 minutes the reaction is completed. So the answer can be either A or C. Answer can be either A or C. So what will be the answer? It is decided by the quantity of B formed. Quantity of B formed, it is not 0.5, it is 1. This is the correct answer. Why? Because 1 mole will give you 2 mole, 0.5 will give you 2 into 0.5, that is 1 molar will be the quantity of B formed. So we have to understand, for finalizing the answer as option C, we have to understand it is a zero order kinetics. We need to know this formula and we need to apply and find out what will be the time for completion. Number 1. Number 2, what is the quantity of B formed at the end of the reaction? It is 2 times the quantity of A taken for the reaction. Is that clear? Fine. Next one. A person is declared as diabetic if his or her blood sugar glucose exceed 160 milligram per deciliter when tested 2 hours after meal. If in some countries it is reported in the unit millimole per liter. If a person has a blood sugar 10 millimole per liter, is he or she diabetic or not? So 10 millimole per liter, that is the observed sugar level. Is it diabetic or not? Diabetic decided by this unit, 160 milligram per deciliter. Okay. So let us see, 10 millimole per liter means how it comes. 10 millimole in 1 liter. That means 1 millimole in 0.1 liter, that is deciliter. So in deciliter it is 1 millimole. In 1 liter 10 millimole. In deciliter 0.1 liter it is 1 millimole. 1 millimole glucose. 1 millimole glucose. You know glucose 1 mole. 1 mole is equal to 180 gram. That is 1 mole for glucose, right? So 1 millimole, it will be 180 milligram. So it is 1 millimole means 180 milligram in 1 deciliter. That is 180 milligram per deciliter. That means it is above the prescribed level and the person is diabetic. It is above the prescribed level and the person is diabetic. And the intention of the question, once again, very simple aspect of unit conversion. Very simple aspect of unit conversion, right? You see, 10 millimole in 1 liter. So 1 millimole in 0.1 liter, that is 1 deciliter. 1 millimole means 180 milligram. So it is 180 milligram in 1 deciliter and is above the prescribed level 160. Fine, and is diabetic. And that is the couple of questions which we have selected for the discussion in today's video. And with another video and a collection of some good questions, we will meet in the next one. Okay, bye, see you, take care, do well.